There are different kinds of chemical bonds. All bonds form because they lower the potential energy between the charged particles that compose atoms. So as two atoms approach each other, there are a number of complicated interactions. You have repulsion between the nuclei. The nucleus of the one atom is positive, and so is the nucleus of the other atom, and like charges repel each other. We also have electrons on both atoms. Those are all negative, and those are going to repel each other. And then we have the attraction of the electrons on one atom for the nucleus on the other atom. And so we've got all these different interactions together. And a bond will form, those atoms will stick together if the result of all those interactions is a lowering in energy, a net reduction in energy. So the first type of bond we'll talk about are ionic bonds. So we talked about ionization energies, and metals have low ionization energies, which means it is fairly easy for them to lose an electron. When they do that, they become cations. Nonmetals have negative electron affinities, meaning that if you give them an electron, they release energy. And so that's a favorable thing as well. Nonmetals form anions by gaining electrons. So when this happens, you have a nonmetal losing an electron, a metal losing an electron and a nonmetal gaining the electron. They're sort of cooperating. Here I'm going to give you this electron. Oh, great, I'm happy to have this electron. And now you have a positive charge and a negative charge. And those two ions are attracted by their opposite charges. So in an ionic bond, we have the transfer of electrons. This is a preview of the other two. So this is ionic bonds. That's going to happen between metals and nonmetals. And we learned that when we learned about nomenclature. Covalent bonds happen between nonmetals, and metallic bonds happen between metals. And so we can look at the essential difference here: electrons transferred, electrons shared, or electrons pooled. So in a covalent bond, we have a sharing of electrons. Nonmetals like to gain electrons and form anions, but if there's not a metal around to lose an electron, they can't convince another nonmetal to give them an electron, because nobody wants to do that. So instead, they share electrons. And those shared electrons will interact with both nuclei and cause those atoms to be pulled together. So the most stable arrangement is here when you have that shared electron between the two positively charged nuclei. That maximizes the attractions between the electrons and the nucleus. That lowers the energy a covalent bond is formed. So the key for covalent bonds is that we have shared electrons. That prefix co refers to sharing, right? Co-sleeping, a co-op, co-ed, it's sharing, right? So, and the valent refers to valence electrons. So this is literally sharing valence electrons, covalent bond. Metallic bonds happen between metal atoms. Metal atoms lose electrons easily, but they don't gain electrons. So if a metal's going to lose an electron and there's nobody else to take it, where does it go? Well, it just kind of swims around. The simplest model here is called the electron C model. I don't think there's a picture. No, I'll have to draw a picture. So you can imagine the nuclei of these different metals. And of course, they have a bunch of electrons, right, in their various levels and everything. But here we're talking about one of the valence electrons. And they will let one of the valence electrons come out. And I imagine this as being like a neighborhood where these orange things are houses where families live, and the electrons are little boys. Little boys sometimes behave like electrons, rather unpredictable, right? You never know what they're going to do. And so here, the little electrons are going out to play in the neighborhood. And this is back when I was a kid, when you could just, they sent us outside and said, okay, when the street lights come on, come back. And that's when you knew you needed to come home, because it was going to get dark soon. And you just went out and you did stuff and you ran around in packs, and it was just great. So imagine what that might be like. But here we have all these electrons. They're just kind of running around the neighborhood. They are not attached to a specific nucleus anymore. They're just around. But all of these families, most likely mom, of course, back then for sure, mom's home and she's looking out the window. You know, if somebody was going to scream or something, she would be aware and go out there and find out what's going on. So she's kind of watching out, and the parents are friendly with each other. They know each other because the kids are playing together. And so these children running around the neighborhood kind of hold the neighborhood together. So that's my best analogy for the electron C model. Okay? So all of these electrons are basically like in a pool. It's like everybody's contributing 1 or 2 electrons to the pool, and then those electrons are shared. They don't belong to any particular atom. So those electrons are delocalized over the entire metal. Any questions?